Hi everyone, this video is on cardiac auscultation and how it relates to the semilunar valves and the atrioventricular valves. Here I have two pictures from the TEMA textbook, the 3rd edition, showing at the top the semilunar valves, which are the aortic valve and the pulmonary or pulmonic valve. So here is the aortic valve, and here is the pulmonic valve. And how do I know which one is which? Well, the aortic valve has the left and the right coronary vessels emanating from it. Here is the right coronary artery, and here is the left coronary artery. I know that because the left coronary artery has another branch, the circumflex artery, and also the left anterior descending or the anterior interventricular artery. In fact, actually on this image just to the right of it, you can see the ostia or the holes for the right and left coronary artery. So this image on the semilunar valves is showing the semilunar valves when they're opened during ventricular systole. In other words, when the ventricles are contracting. By contrast, we have down here on this image the atrioventricular valves, which includes the tricuspid valve, which is the gateway between the right atrium and the right ventricle, and the bicuspid valve, or mitral valve, which is the gateway between the left atrium and the left ventricle. When you consider blood flowing in series through the heart, the blood flows through the tricuspid valve before the bicuspid valve, and a mnemonic we can use to remember that is whenever you go shopping, you always try before you buy. So try before you buy. As you can see here, the structure of the valves is very different. The semilunar valves are like cusps with a nodule on the end here, and when the cusp closes, that nodule helps prevent those semilunar valves from prolapsing. In other words, collapsing in order, which would allow blood to regurgitate or backflow, versus the atrioventricular valves, which kind of look like jellyfish. Or kites. They have this nice leaflet-looking structure, which are really flimsy, and then they're tethered down by these chordae tendineae to the papillary muscles. The analogy I like to use is that the papillary muscles act as muscle men, which are holding the kite strings to keep the kite from flying away as blood is trying to forcefully go back through the way it came. In other words, regurgitate back into the atria. And these valves prevent that from happening. So the valves are open here on this diagram at the bottom during atrial systole or ventricular diastole, which is essentially happening about the same time. When we talk about systole and diastole in general, that generally refers to the state of the ventricles. So when we say systole, we're talking about ventricular systole, and during that time we would expect the aortic and pulmonic valves to be open. When we're talking about the atrioventricular valves open, that is during ventricular diastole. In other words, the blood is flowing from the atria into the ventricles. Okay, so how does this have anything to do with cardiac auscultation? Well, when the valves close, they cause a sound. And the typical sound you are probably familiar with is lub and dub. So what is the lub and what is the dub? Well, the lub sound is when the semilunar valves are closed, or excuse me, the atrioventricular valves are closing, but you can see that here on the semilunar valve figure. So when these are closed, that makes a lub sound. When the semilunar valves are closing here, that makes a dub sound. So we're just going to listen to that for a few seconds. This is what it sounds like. Lub dub, lub, dub, lub, dub, lub, dub. And so the lub is, again, the atrioventricular valves closing, and the dub is the semilunar valves closing. Okay, so I picked up that heart sound from blaufus.org, blaufus.org. It's a fantastic website that was produced by UCLA, and it goes through all sorts of different heart sounds. It's one of my favorites, and it does a really good job at talking about prolapses and all sorts of things that can go wrong when blood is going where it shouldn't be. So how do we auscultate for that? How do we listen for that? We'll scroll down here. This figure shows very nicely, also from TIMA, the places where you would auscultate the valves. And what we're trying to do here is take advantage of a physics principle called the Doppler Effect. That effect is the principle that when I'm listening for a wave coming towards me, it is going to be at a higher frequency than a wave going away from me, which is going to be going away at a lower frequency. Now, the frequency actually is no different as far as what's generating the frequency, but what I perceive is different when that frequency is coming towards me or going away. The analogy is the ambulance effect. If I'm on the highway and I hear an ambulance, when it's coming towards me, it's very high-pitched and I can really hear it, but as soon as it passes me, the pitch goes down. In fact, there's a perceived volume decrease as well. So on the heart, notice that what's labeled here is the aortic valve, pulmonary valve, the right atrioventricular valve, which again is the tricuspid valve, and the left atrioventricular valve, which is again the mitral valve. And we want to hear for the valve by listening for the blood as it flows towards us. Okay, so we are going to, if we want to listen to the mitral valve, we're going to place our auscultation site. We're going to place the bell of our stethoscope at about the fifth intercostal space on the left side, because blood is flowing from that valve towards us in that direction. Likewise, if we want to listen to the tricuspid valve, we're going to place the bell of the stethoscope about at the fifth intercostal space, but closer to the sternum because blood is flowing in this direction. If we want to listen to the pulmonary valve or pulmonic valve, we'll listen in the second intercostal space because blood is flowing toward it there. And the aortic valve is the odd duck here. We're going to listen for that valve because blood is flowing away from the heart towards the right side, because the aorta, remember, is a curved structure. We're going to listen for that in the second intercostal space on the right side. So notice that for three of the valves, we're going to listen for them on the left side of the body. The mitral valve, we'll listen for it at the fifth intercostal space, and this dotted line happens to correspond to approximately the midclavicular line. And we're going to listen to the tricuspid valve in the fifth intercostal space next to the sternum, and we're going to listen for the pulmonic valve in the second intercostal space next to the sternum, and then the aortic valve in the second intercostal space, but on the sternum on the right side. And that's summarized nicely right here in this table. So aortic valve is the odd duck, left for the pulmonic, left for mitral, left for tricuspid, and then notice the intercostal spaces. Second and fifth is what we're looking for. Okay, I think that does it for this video. If you have any other questions, please feel free to contact me. Thanks a lot. Bye.